Hello, dear students. In the last class, we have seen moments and different types of moments, like moment about origin, moment about mean, and their relationship between. All this we have seen in the last class. Now we are going to see a new terminology, that is skewness. What is mean by skewness? Skewness is degree of symmetry of a distribution. What is mean by that? If you have a frequency table like x and f values, you can plot the graph of that table, x in the x-axis, f in the y-axis. That you can do, right? So here, if you plot, I'll draw here like this. In this direction you are plotting f, in this direction you are plotting your x. So you can mark the points from the table for corresponding xf pair. You can mark the points, then you will get a curve like this, or in this way, or in this way, or in this way. Almost it will not be equal to same, it will have some changes. Whatever, it will looks the same, but this is cumulative frequency, not just frequency, it is cumulative. Sorry, it is frequency itself. Sorry, frequency. Okay. So what happens is, the value for which the maximum comes will come here, see, on this place, and then it is in the decreasing format on both sides. Likewise here also, value comes maximum will come here, then decreasing on both sides. The same here also, but there is a change in the shape. What is that? Actually, this is your mean position. From the mean position, it is deviating to the left. Here, from the mean position, mean values are coming in this position. This is the mean value, x bar comes here. Okay, here mean value comes here. Here mean value comes here. So the slant of the data curve is to the left of the mean, then we will tell it as positive skewness. If the slant this side is coming to the right side of mean, then we will tell it as negatively skewed. And here you can see mean, median, mode all comes with the same line, means all these three are equal for this symmetrical distribution. Okay, so this is positively skewed, this is negatively skewed, this is symmetrical. There is no skewness here. Here it is symmetry. So these are the three types of skewness that. But how can you check the skewness of the data? Whether the data is coming closer to some end values. This is like middle value is getting more frequency, correct? Here it is, this is coming some other value to some end of the frequency, like x1, x2, etc. If we are writing some values, it is coming maybe in the beginning values have more frequency, or in the end values has more frequency. Likewise, it can come. So then the skewness comes like this. Okay, to this side or that side, the positive skewness and negative skewness. The left it is going positive, right it is going the peakness, that is called the negative skew. Now to check the skewness, we have a measure, that is called measure of skewness. Measure of skewness we will find by whatever we have learned up to this. Using that we can find the measure of skewness. This is very important question for the examination. Here we have different types of measures. We will tell the measure of skewness as coefficient of skewness. Okay, so coefficient of skewness are, I have given in 5 ways. First one, Pearson's first coefficient of skewness, then Pearson's second coefficient of skewness. So these together will always ask to find. Then quartile coefficient of skewness, then 10 to 90 percentile coefficient of skewness, then the last one, moment coefficient of skewness. We have the formulas here. What is the first formula? Pearson's first coefficient of skewness means mean minus mode by standard deviation. Or another way, if you write, how can you write? X bar minus mode divided by standard deviation we will write by S, correct? So this is the representation. And using empirical formula you can avoid mode term and you can write it with the mean and median term that is written here. So that is called Pearson's second coefficient of skewness. So this is equal to 3 into mean is, you can write x bar minus median divided by standard deviation representation S. Okay. Now, so you have two types, that is Pearson's first coefficient of skewness, then Pearson's second coefficient of skewness. So already you know how to find a mean, how to find mode, how to find standard deviation. How to find standard deviation. All these formulas you have already learned. Whatever be the data grouped or ungrouped, you can find all these things. Then you can find the coefficient of skewness. Now, next one is quartile coefficient of skewness. The same way, the formula is Q3 minus Q2. That is the last two quartile difference minus first two quartile difference. So three quartiles only we have Q1, Q2, Q3. Q2 is same as your what median, correct? So here you can rewrite this formula once again. How can you write? Minus Q2 minus Q2 minus 2Q2 will come. When you open the bracket, minus Q2 minus minus plus Q1 will come. So you can write this as Q3 minus 2Q2 plus Q1 divided by Q3 minus Q1. Okay, Q3 minus Q1. So you can rewrite in this format. This is called quartile coefficient of skewness. All quartiles we have used: first quartile, second quartile, third quartile. All formulas you know, you can use that to find this coefficient of skewness using quartiles. Now, next is 10 to 90 percentile coefficient of skewness. For this, we are taking P50. P50 is again same as your median value. Okay, so P50 we are choosing. So this again I can rewrite P90 minus 2 times P50, 50th percentile, plus P10 divided by P90 minus P10. So P90 minus P10. Okay. So you can find the 10 to 90 percentile coefficient of skewness by using this formula, or in simply this formula you can use. All the percentiles we have used here: 10th percentile, 50th percentile and 90th percentile, used to find the 10 to 90 percentile coefficient of skewness. That is from the middle how much it is deviated. That's what everything we are doing. See, mode is also taken like a middle value, or both you can consider. We have consider mode and median here. In these cases we have taken Q2 and uh, P50, that is middle concept. So from that the deviation we are considering. Now last one is moment coefficient of skewness. Using moments, how to find the coefficient of skewness? Here we are using the moment about mean actually. So M3 by root of M2 cube we have taken. This is the moment coefficient of skewness. So third moment, if you have to find up to third moment. So third moment about mean. So to find about mean, what you have to do, you have to either use direct formula about mean, or you have to find central moments, that is m1 m1 dash m2 dash, likewise you have to find. Then you substitute in the relationship formula to find this moment about mean. In whatever way you can do this, I can rewrite this in another way, that is m3 by, I can write root m2 whole cube, correct? Exponents can be interchanged, root and 3 can be interchanged. So what is root m2? M2 is your variance, correct? Second central moment is same as second moment about mean is same as your variance. So root variance is standard deviation. So you can write this as M3 by S cube. So either you can write in this way, or this will be better to for the calculation purpose, correct? So these are the 5 types of skewness. And one more is there, and that is called that is b1. B1 is equal to a cube. What is a cube? this moment coefficient of skewness is named as A3 and B1 is named as whole cube of it. Okay, so this is used for normal distribution. No need for here, just for your information I told. So these are different types of skewness, coefficient of skewness. There will be a data set. You are asked to find the coefficient of skewness. So if you are asked to find Pearson's first and second coefficient, you have to find mean, median, and standard deviation, and mode also you have to find for finding the first. All these four things you have to find: mean, median, mode, and standard deviation. And to find quartile coefficient and percentile, you have to find all the three quartiles and all the three percentiles. Then moment, you have to find the second and third moments about mean. Then you have to calculate the all other formulas are one and the same, just a calculation only you have to do, and you have to substitute in the formula to find. Now, one more thing terminology you have to study is kurtosis. What is mean by kurtosis? We have seen skewness. What was the skewness? Skewness is the degree of symmetry of the distribution. So, how much to this side or that side is it is tending, slanting. That's what we are checking in the skewness. Okay, in the kurtosis, degree of peakedness of the distribution means how much closer it is all the data to one, or it is distributed. That's what we are checking. How much the curve is bigger or smaller or flatter, that is the concept of kurtosis. So here you can see three curves. See, first, second, three type curves they have written. First one, that is more peaked curve, right? That is called leptokurtic, and one curve is almost flat like this. Okay, so this is almost flat like curve. That curve is called, that type of kurtosis is called platykurtic. And in between, it is not too much flat or too much peaked. That type of is called kurtosis is called mesokurtic curves. So this is for normal type of distributions, and other there will be changes. So here you can see, here the frequency is very less, and when coming closer to middle value, this is coming more and more, frequency is bigger and bigger, right? So most of the values coming closer to this region, right? All the x values frequencies are coming here only, means whatever entry you take, that comes in this region. Platykurtic means what? The distribution means almost flat, like it is going, means from all the x values are equal, frequencies are coming everywhere, almost everywhere it is coming same frequencies. And here mesokurtic, it is almost equal. For the middle value they have almost maximum, and the others are symmetrically distributed to both sides. That is called mesokurtic. These are all a general format. Our data curve can come in a different format and all, but for as a good sampling or whatever data we are collecting, this should be followed. These criteria should be followed, then only it will be a good distribution or good data collection. That's why we are learning all these things. Okay, so these are the three types of kurtosis here as well. How to measure the kurtosis? We have two measures: moment coefficient of kurtosis and percentile coefficient of kurtosis. Only two kurtosis we have to learn. First is moment, using moment. What is that? M4 by M2 square. That is another way you can write it as M4 by M2 means your variance, right? M2 is variance, so you can S raised to 4 it will come. M2 is variance, that is S square. S is standard deviation, variance is S square. So S square is same as your M2. So M2 square means S raised to 4. So you may use this the same, no need to use this, just for information I have given. So first find the second central moment, then fourth central moment, then you can substitute in this to find the moment coefficient of kurtosis. Then percentile coefficient of kurtosis, if it asks, you have to find Q by P90 by minus P10. What is P10 and P90? 10th and 90th percentile. And what is Q? Q is the quartile deviation. Quartile deviation, that you know the formula. What is that? Q3 minus Q1 by 2. So that quartile deviation you have to find means you have to find the first and third quartile and subtract to find divide by 2 to find quartile deviation, then divide with the percent 10 to 90 percentile deviation that you have to do. So divide then you will get percentile coefficient of kurtosis. These values will give you an idea of how much peaked the data it is. So that's the measures. So these are very important. It will come for a higher marks because so much calculation involved. To find moments it will take time because these are central moments. So for that you have to first find the other moments like m1 dash m2 dash. You have to find that is called row moments. So that moments you have to find first, then you have to find this, or you can directly find this using minus x bar. That also will time taking. And here also to find q1 q3, all these are time taking, so it will be lengthy problem. So it will come for higher marks. So carefully do the calculation. You have to perform the calculation for any one table you have already done. You can choose from your note a table in which you have calculated mean, median, mode, standard deviation and all. You can take, using that you can perform to find the coefficient of skewness of Pearson's first and second. And in the from the problem in which you have found the quartiles, you can find the quartile coefficient. And from the other problems like the same you can find. And the last problem we have done, we have found the central moments. Using that you can find the coefficient of skewness for that data set. In the same way, kurtosis also you can find one problem. The whatever you have done in the last classes, that table only you take. No need to calculate it again and again. Once you have done the calculation, you use that again here to find the coefficient of kurtosis and coefficient of skewness. Hope the formula is very clear. It is easy. Just all the issue comes for you will be confusion among the formulas. So you have to learn the formulas thorough. You write the formulas in a one page, all the formulas together in one page. Learn one by one, compare one by one what is the difference between each formulas. You have to check and which formula is for skewness, which formula is for kurtosis. Identify and write by your own one or two times by heart. Then it will be good for you to do the problem. If the formula is wrong, you will not get any mark. You will get 0 marks for the problem. So be careful on formulas. Try by yourself. So try all the coefficient of skewness and kurtosis with already done data set, already calculated data set. Use that previous calculated data to find all this. Okay, and that's all for today. Almost we have covered the syllabus. Now if you have any doubts in any of the previous topics or any particular topic, you may mention in the group. We will discuss online in live classes at any of these coming days. By this Friday, we are closing the uh, D5. So in this week you may ask for online live class, so that we can clear your doubts at any point of time with the dynamics or my class. Whichever point it is not clear for you, I will explain live. So those who want to clear the doubts may come for the live classes. You may suggest the time. Hope you will suggest a time after 1:30, because up to 1:30 you will already have lectures. So after 1:30 some hour you suggest, we will come online and clear the doubts. You are free to ask any questions from the question paper. If you have any doubts you can ask, or from exercise if you have any doubts, ask in group. Do not forward private messages, because I will not see the messages frequently. I will watch the group always. So better you post the problems or questions in the group. Now one more task we have to do is we have to solve as much as problems from the exercise. So I have a plan to do this. So I will give you the message in the group later. So for today's homework, you perform all the coefficients of kurtosis and skewness for any one of the data you have already done. Thank you for today.